This video is over how to solve inequalities and also graph it. So Julia bought a notebook for $4 and a pen for N dollars. She spent at least $7 solving graph. What does it mean to you at least? Give me some examples. $10, $12, $7.25. What about $7? Let's think. At least. The least amount she spent was $7. So yes, $7 is perfect. So all the numbers I mentioned were equal to it. So not these. And more. So it must be this one because this side is 4 plus n is more or than $7 or equal to $7. So now we need to solve it now. Let me get my calligraphy pen. I'll use green. I need to isolate n. What is the inverse of 4? Minus 4. Minus 4. Cancel. N is greater or equal to $3. That means her pen must have cost more than $3 or equal to $3. So close dot for $3 because we know that is equal to $3. So she spent exactly $3 or more than. So we're going to highlight to the right numbers that are more than $3. So she could have spent $3.01 on her pen plus a notebook, which is 701, which is greater or equal to $7. So we have our inequality. 5m is less than or equal to 10. I'm going to assign a different number to each student, and you will tell me if your number is true or false. For example, 5 times negative 5 is negative 25. Is that less than or equal to 10? Yes. Negative 5 times negative 4, that's negative 20, less than 10. 5 times negative 3 is negative 15, less than 10. 5 times negative 2, less than 10. 5 times negative 1 is negative 5, less than 10. 5 times 0, 0, less than or equal to 10. 5 times 1 is 5, less than 10. 5 times 2 is 10. Is it less than 10? No. But is it equal to 10? True. 5 times 3 is 15, less than 10? No. 5 times 4 is 20, less than 10? False. 5 times 5 is 25, less than or equal to 10? False. So negative 5 is true, 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 all the way to 2. So all the numbers that are less than 2. But 3, 4, 5 are canceled out. How did you like going through a number line and figuring out one by one? Or would you like to solve it algebraically? I do. This is m. I need to isolate m. What operation is this? It's a multiplication. What's the inverse of multiplication? Division. So I divide by 5. I'm trying what number I'm trying to get rid of? 5. So I balance on the other side. This cancels. 10 divided by 5 is 2. M is less than or equal to 2. So let's go back. It saved a lot of time, didn't it, solving algebraically? Let's see. Whoa! All the numbers I circle are less than 2 or equal to 2. So it really does work. So close dot. And it has to be less than 2. So I'm going to highlight all the numbers that are less than 2, which is all of these. So all of these worked. Let's try another one with a table. 3m has to be greater than 9. So let me use my calculator. 3 times negative 5 is negative 15. That is not greater than 9. 3 times negative 4 is negative 12. Nope. 3 times negative 3 is negative 9. Nope. 3 times negative 2 is negative 6. Nope. 3 times negative 1 is negative 3. Nope. 3 times 0 is 0. Is that greater than 9? False. 3 times 1 is 3. Nope. 3 times 2 is 6. Nope. 3 times 3 is 9. Is that greater than 9? No. Close. It's equal, but it's not greater. 3 times 4 is 12. Is that greater than 9? True. 3 times 5 is 15. That's greater than 9. True. So only 4 and 5 I'm able to circle, but the rest all cancel out. Would you like to solve this algebraically? I do. I need to isolate m. What operation is this again? Multiplication. The inverse is division. Division. This cancel. 9 divided by 3 is 3. So m has to be greater than 3. Are all the numbers I circle greater than 3? It works. So it's open dot, and I have to highlight numbers that are greater than 3, such as 3.5, 3.1, 3 and 9 tenths, 4, 4.5, 5, 6, 7, 8, and so on. So what you're going to do now is you're going to be practicing with several questions. So some of them will be addition, some of them will be subtraction, some of them will be multiplication, some of them will be division. I need to solve each inequality, represent the solution on a number line. So I need to isolate A. The inverse of plus 8 is minus 8. Minus 8 does cancel. So negative 2 minus 8 is like saying negative 8. That's like negative 10. So here's negative 10, negative 9, negative 8, negative 11, negative 12. This is a negative number line. A has to be less than negative 10. Open dot because this doesn't include negative 10 not equal. And all these numbers are less than negative 10. Remember, a number line goes from least to greatest. Next one. Here's a subtraction one. Need to isolate G. I do the inverse of minus 3 with plus 3. Plus 3 does cancel. 4 negatives with 3 positive is negative 1. So G has to be greater, more than negative 1. But can it equal to negative 1? Nope. Open dot. And all of these numbers right here are greater than negative 1. So next one. 8t is less than or equal to 32. I need to isolate t by doing the inverse of multiplication with division. Division, because I'm getting rid of 8. That canceled. T is less than or equal to 4. So 4, 5, 6, 3, 2. It can be equal to 4, so close dot. But it has to be less than 4. So it goes this way. Next one. F divided by 5 is greater or equal to negative 3. So what's the inverse of divide 5? Times 5. Times 5. Just cancel. F is greater or equal to negative 15. So negative 15, negative 14, negative 13, negative 16, negative 17. It can be equal, so close dot, but it has to be greater than negative 15. So I'm highlighting to the right. And I believe this is our last example. Yes, it is. 35 is greater or than 5j. I need to isolate j by doing the inverse of multiplication with division. Division, this cancel. So 35 divided by 5 is 7. 7 is greater than j. Again, to be solved, you can leave it in this way, but I like personally putting the variable on the left side of the inequality or equation. So let's see, j is facing the less than. So it is j is less than 7, so all these numbers are less than 7. Is it equal to it? No, it's open dot. Less than 7. All right, so that's how you solve inequalities using multiplication and division that are positive. All right,